So again, we're going to talk about end behavior and graphing polynomial functions. So there are concepts that would be a lot easier for me to show you in person, as I would be doing a lot of like movements just to kind of show you what's happening with the graph and the behaviors, but we don't have that. So you're going to have to really listen to my words and look at what I put down here. I will make sure to put the notes on Google Classroom so that you can refer back to them, but everything has similar functions, okay? So, let's begin. I am going to determine different polynomial functions on how they are going to look based off of their behaviors. With this COVID-19, the graphs do show very similar behaviors and how they function. It's just how the graphs actually look. And I actually want to show you. Well, I'll show you at the end. When we have a positive leading coefficient, a positive number could be any like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a positive number with an even degree, throw out an even number besides 2. I heard somebody say 4. Let's see, did somebody actually say 4? Yeah, hey Tyler, you said 4. Okay, so looking at that number, 4, what does 4 mean in terms of graphs? What do you think that 4 means? The fourth power. What do you think that fourth power means in terms of our graph?
That'll go up by 4 each time?
Not necessarily, and I forgot to put this. Not that it's going to go up 4 times or go up 4 amount. This means that it's going to have 4 intercepts. It's going to go through the graph 4 times. So the way a positive and even graph looks is very similar to when we have y equals x squared. What does x squared graph look like?
It has 2 intercepts.
It does have 2 intercepts, but what does the graph look like?
A parabola.
Very good. It looks like a parabola facing up. So that's going to be pretty much the same idea as y equals x to the fourth power. It does create a parabola. So we're going to see that our graph is going to start facing up, and it's going to go through the x-axis 4 times. Now this graph that I'm making is just a rough sketch. This is not actually what it would look like, but it's a very rough sketch. But the thing to note is that because it was to the fourth power, it went through the x-axis 1, 2, 3, 4 times. And that exponent always represents how many times a graph pretty much goes through the x-axis. Okay? So now looking at this graph on the left side, this is what we call end behavior. And yes, Tyler, if it was negative, it would be flipped face down. But because this is positive, it's flipped face up. So on this side, our y is it going to positive infinity or negative infinity in terms of our y? It is going toward positive infinity. There you go. As y goes to positive infinity, as x, so now on the left side, is x going to negative infinity or positive infinity? No, if it's on the left side of this point, it's going toward negative infinity. Because as y is going on the left side to positive infinity, x is going in the negative direction. On the other side, as it goes through these challenges, y is still going in what direction? Positive infinity. So as y goes to positive infinity on this side, is x going to negative infinity or positive infinity? Very good, positive infinity. So on the left, what this statement is saying here is as y is going to positive infinity, x is going to negative infinity. And on the other side, as y is approaching positive infinity, as x is also approaching positive infinity. Are there any questions about that so far? These are just the rules of how, or the behavior of this type of function. How do I find the degree? They'll give it to you. They'll give you the degree. And I'll show you some examples below how to find them algebraically. This is very interesting stuff because when we are looking at the behaviors, and I'm just going to show it to you because I really think it's important that you guys really understand how math works. Okay, so I want to show you guys the COVID-19 cases, and I'm going to show you guys how to interpret these graphs. This is what they pay big bucks for you to see. Now, can you guys see this graph that I'm showing with the COVID-19 cases? Okay. So right now, the way a mathematician would look at this graph is we don't necessarily have to see these up and downs. We don't necessarily care for that. What we see is that this graph, if we're looking at the slope, is it increasing or decreasing?
It's increasing.
It's increasing. So we see this as a linear function. We see that there is an incline in the COVID-19 cases, meaning whatever we're doing in our nation is not helping. Whatever we are doing as a nation, we see that the cases are still increasing and they are not decreasing. Now we do see these peaks and these valleys, but we're seeing that on general basis, we should be doing whatever's happening here where we see the decrease, but we're seeing that overall everything is increasing. And so let's see, I'm trying to see if we can find a similar graph. New York. Okay, now with New York, what do we see? What type of graph do we see? If we look at this, an upside down U, we see a what? And feel free to throw it out. Throw out your ideas. We're seeing a decrease. Now, is this linear or is this a parabola? It's a parabola. It is a nonlinear function, meaning it's a parabola, because we see here that it was increasing, but now it is decreasing. So this is what we would consider a parabola that would be like negative x squared, because we see that this graph is pretty much face down. And we see that the point in which it started to decrease was at this vertex. This would be considered the vertex, because we see that some trend happened where now we saw a decrease. We see that this decrease is happening. And then if we look at Arizona, we see that it was steadily increasing, or it was starting to plateau, which was really not showing any significant movement. But then now it's starting to increase. Next semester, we'll talk about logarithmic functions, where we see how bacteria can increase or exponentially grow if it's not treated. We see in Arizona right now that they had a steady growth, and now it's becoming exponential. So these are different scenarios where we are seeing different growths and decays. Okay? That's how mathematicians are looking at these functions. And this is what they pay people to look at when they're making their analysis. Okay? So I just wanted to give you a little quick idea of what all this stuff means. Because this is teaching you the fundamentals, but when you get into different types of math, when you get into college, you'll get to see why they actually, what do they actually do with it. Okay? So now, we saw two examples of linear and parabolas. So now we look at this one with an odd degree. Still positive leading coefficient with an odd degree. So an odd degree would be something like, let's say, 3. Okay? So what does that 3 indicate? What does that 3 tell us?
There's going to be 3x-intercepts.
Very good. There are going to be 3 x-intercepts. So now the general equation that matches this is y equals x. And what type of graph does y equal x mean? What kind of graph would this look like? Very good. It's going to be a positive linear graph. So with this one, we are seeing growth like we saw in those other charts. So it's going to start below and it's going to end up top. So the graph will look like 1, 2, 3. So the graph went through 3 times. So now for here, because we saw that the graph goes 3 times, now we're going to see what the end behavior was for this function. So down here, is y approaching positive infinity or negative infinity? Very good. So y approaches negative infinity as x approaches. Is it going toward positive infinity or negative infinity? Very good. So y approaches negative infinity as x approaches negative infinity. On the other side, y is approaching
Positive infinity.
and x is approaching.
Positive infinity.
Very good. You guys are becoming good analysts. So we're seeing that there's a positive trend. We might see some dips and some valleys in here, but we're seeing for the most part, these trends are happening at the ends. Okay? So now we know that negatives essentially flip our graphs. So below, now we're going to deal with negative numbers. So when we have y equals negative x squared, what does our graph look like? What is our graph going to look like? So Tyler, you made a comment earlier that would be true, and you said the parabola, or Andrew said the parabola is going to go down. That's correct. So our graph is essentially flipped. So we're going to have a face down parabola. So now we're going to have that same type of behavior. So now if I put to the 6th power, what should our graph look like? How many, what does that 6 represent?
Number of x-intercepts.
Very good. I want to keep saying this because I want you to keep hearing it. That's the number of intercepts that you're going to have. So we're going to have 6 intercepts. So now instead of our graph facing upwards, for this one, our graph is going to face downward. So now we're going to go through 1, 2, 3, 4, 5, 6 times. So our graph would go through 6 times. So now on this side, is y approaching negative infinity or positive infinity?
Negative infinity.
Very good. So as y is approaching negative infinity as x is approaching.
Negative infinity.
Very good. And on the other side, y is approaching
Negative infinity.
as x is approaching.
Positive infinity.
Very good. You are getting it. So that is going to be the behavior for this type of graph. Now for our last one, this one is going to be y equals negative x, which is essentially going to look like an arrow going down. So let's say we have negative x to the 5th power. So our graph is going to start here and end there. We're essentially looking at a graph where it is decreasing. So we have 1, 2, 3, 4, 5. So our graph is decreasing. So as y, so y is approaching up here. What is it approaching?
Positive infinity.
Very good. As x is approaching,
Negative infinity.
and on the other side,
Y is approaching negative infinity.
as x is approaching.
Positive infinity.
Very good. You should notice that the behaviors of x are always the same. The behaviors of x never change. Yes, Matthew.
Can you explain that second part?
Which one? This one?
The negative infinity. Yeah. How do you find that again?
For like, if I'm looking at the graph, I look at it in terms of the left side and the right side. On the left side, our graph is showing that the arrow is increasing. So that means the arrow is continuously going up. So y is approaching positive infinity because it's going up. But because it's on the left side, x is approaching negative infinity because it's going to the left. And on the other side, y is approaching negative infinity because it's going down. But because it's on the right, the x values are positive. Okay. So this is the basic behaviors of a graph. Now we're going to look at this algebraically without a graph. So Taylor, to answer your question before, how do you find the degree? We basically just look at the equation. In terms of end behavior, I only want to pay attention to this first term. I need to find the highest degree and what number is in front of it. Is it a positive number or a negative number? So for number 1, our first term, is it positive or negative? Positive. And is our degree even or odd?
Odd.
Odd. So now we have to find positive odd. So in terms of our 4, it's going to be a positive odd. So is it going to be box 1, 2, 3, or 4? The behavior, is it going to be box 1, 2, 3, or 4?
2.
Box 2. So its end behavior is going to go y approaches negative infinity as x approaches negative infinity. Y approaches positive infinity as x approaches positive infinity. I literally just copy what I have written here and put that as the answer, and that's it. All you're doing is figuring out what the end behavior is based on the graphs that we have. Number 2, do we have a positive number or a negative number?
Negative.
Okay, so we have a negative number. And is it an odd degree or an even degree?
Even.
So which graph is it going to be like? 1, 2, 3, or 4?
3.
Graph 3. You're correct. It would look most like this graph. So it would go y approaches negative infinity as x approaches negative infinity. Y approaches negative infinity as x approaches positive infinity. Okay. Number 3, do we have a positive number or a negative number? Is it positive or negative for number 3?
Negative.
Okay, so we have a negative number. And is it an even degree or an odd degree?
Odd.
So now we have a negative odd. So is it going to look like graph 1, 2, 3, or 4? Put it in the chat. I want each of you to put it in the chat. Just a private chat. Which graph is this going to look like? It is a negative number to an odd power. Negative number to an odd power. Where do we see a negative number to an odd power? A negative number to an odd power. I want to see more responses. Still waiting. We see a negative number to an odd power. Okay, so our answer would be graph number 4. The reason is because we have a negative, which we see here, and odd. 5 is an odd number. So we would write y approaches infinity as x approaches negative infinity. Y approaches negative infinity as x approaches infinity. Okay? Now, for number 4, which graph? Or what do we have here? Do we have a positive number or a negative number? Okay, positive. And is it an even degree or an odd degree? Even. So in the private chat, positive even. Which graph is it going to look like? 1, 2, 3, or 4? Positive even. Gotta put it in the chat. You gotta pick one. Which one, Ronaldo? If you said graph number, let me see how many responses I got. If you said graph number 1, you are correct. These are the exact same as graph number 1. Okay? So that's pretty much how you decide end behavior. You follow those steps so that you can figure out that information. Okay? This was quite a bit of information to take in, but you will catch on. You will have a lot of practice to do on Delta Math. Okay? So this is just one part of what we have to do today. Okay, so now we are going to go from very beginning to the end of being able to graph a function along with figuring out how to graph it. Okay? So, hold on tight. So now, for the graph, in order to graph, we first need the x-intercepts. Based off of what we've talked about yesterday and the day before, what would we need to do in order for us to figure out how to, or what graph we need to do, or where do we even start? Where do we even start with this function? What would you do first?
Check if the first value is positive or negative.
Not quite there yet. We're not there yet. We don't need the end behavior yet because I don't really know how to graph this. I don't know the x-intercepts. How do I basically get this done? We need to factor it. But they didn't give us a, hey, divide this by x divided by something.
List the possible rational.
There you go. List the possible rational roots. So we have 9 and negative 2. So this makes plus or minus 3, 1, 9. Plus or minus 2, and 1. So my guess would be, hey, let's try -1. So we're going to list all our coefficients. Okay, so we drop down 9, -9, 1, -1. Is this going to work? No. So now let's see if +1 will work. So we'd still do the same thing. Bring that down. Did that work? Yes. So we know that 1 is one of our roots. Okay? So we know that this works. So now, what do we have to do next?
Factor to solve.
Very good. We're going to factor to solve. So this is going to be the same thing as saying 9x squared plus 19x plus 2. So now we're going to use our x method. 9 times 2 gives us 18. What two numbers multiply to make 18 but add to give you 19? 18 and 1. We have 18 and 1. This gives us 2, and that leaves us at 1/9. So now I have, because that was a +1, we have x minus 1, x plus 2, and then 9x plus 1. So now we're going to ZPP it to get our roots. So we have +1, -2, because we're just doing the opposite. And then the opposite of this, -1/9. So now we're going to examine the leading coefficient to determine the graph direction. So that's like what Matthew was saying earlier. Let's see the first term, which was 9x cubed. Is this a positive or negative number?
Positive.
And is this an odd degree or even degree?
Odd.
Very good. So we know that our graph should look something like this. Okay. So now we're going to plot our points. So -2, 1, 2. -1/9 is going to be like somewhere here, and +1 here. So now we're going to graph it. And that's it. Now on Delta Math, they are going to ask you to be very specific. So you're going to want to make sure that you look at the example to see how specific they want you to do it. But this is the way of being able to graph a function. Okay, so I'm going to show you one more example. But I want you to be very verbal about what to do, because I want you to be able to to talk it out so that when you are doing the Delta Math, it isn't as confusing. Okay, step 1. What do I do?
You have to find a rational root.
Very good. Let's find our rational roots. So we have ±3, 1, ±6, 2, 3, 1. Which term do we want to try out first?
1.
1. Okay, let's try 1. So you list our coefficients. I don't think that's going to work. Let's try -1. Doesn't work. What else should we try? 1 and -1 don't work. So let's try 3. So we have 3, -4, -17. And this is all a part of the process as well. We definitely want to try and see what works, what doesn't work. And sometimes it does take more than once or twice, 3 times. So 3, 9, 5, 15, -2, -6, 0. 3 works. So 3 is one of our solutions. We got very lucky because I know there's opportunities where things may not work. Okay, so now, what do we have next? What do we do next?
You have to factor to solve.
Very good. So we have 3x squared plus 5x minus 2, -6, 5. See, I'm always putting the 3 or the a that needs to be there. Make sure you do that because if you don't, you're going to make a mistake. Okay, what two numbers multiply to make -6 but add to give you 5?
6 and -1.
Very good. This simplifies to 2. So we have x minus 3 because we do the opposite of that. X plus 2, 3x minus 1. So our solutions, +3, -2, +1/3. I'm just doing the opposite signs of these. So this one's -2 and +1/3. Okay, what do I do next? Step number 4, read step number 4.
Examine the leading coefficient.
Very good. We're going to examine the leading coefficient. Do we have a positive or negative number?
Positive.
And is this an even degree or an odd degree?
Odd.
Very good. So our graph is going to look like that. So now we plot our points. So I have -2, 1/3, and 3. So we graph. And that's it. Questions, comments, concerns?